Today we're going to go through the nitrogen cycle and how it relates to the law of conservation of mass. So yesterday when we did the nitrogen cycle, you should have saw a few things. You should have saw that there are two different kinds of bacteria, Nitrosomonas and Nitrobacter, that play an important part in the aquarium. The Nitrosomonas eats ammonia, and this is the chemical formula for ammonia. Okay, now there's oxygen in the tank that it also metabolizes in its body. The Nitrosomonas eats the ammonia and poops nitrite. Okay, and that's the first thing we test for, or the second thing we test for in our tank, nitrite. All right, it also gets rid of other waste, water, and hydrogens as well, but this is the most important thing here. So again, once again, the Nitrosomonas eats ammonia and poops nitrite. The second bacteria in the tank, called Nitrobacter, that will eat the nitrite. So it literally eats the poop of the Nitrosomonas. So the Nitrobacter eats the nitrite and poops nitrate. Now nitrate, chemical formula is NO3. And in this form, it's the least toxic of them all. And this is the form that is used in fertilizers, and it's plant food basically. So we have a toxin that this one eats. It poops another toxin. And then this one eats that toxin and poops a plant food. Okay. It's a very interesting cycle that is very beneficial to all the creatures involved inside the aquarium. Now, how does this relate to the law of conservation of mass? Well, the law of conservation of mass basically states that the mass of the reactants, that's the mass of all these molecules and atoms on this side, has to equal all the mass of the molecules and atoms on this side of the equation. So the reactants have to equal the products. Okay, so if we counted all these up here, and I broke them down for you in here to make it easier, there's 2 nitrogens in here, there's 6 hydrogens in here, and there's 6 oxygens. When the Nitrosomonas eats those, it doesn't really change them to something new, it just changes their forms and their placement of them. So it takes those same 2 nitrogens, 6 hydrogens, and 6 oxygens and rearranges them into these, and we still have the same ones. They're just in different forms now. 2 nitrogens, 6 hydrogens, and 6 oxygens. The same amount. The mass of the reactants equals the mass of the products. Same thing with the Nitrobacter. Okay, it's a little different starting point here, but there's 2 nitrogens, 6 oxygens are the reactants, and after it eats it and eliminates it through pooping, it has the same amount. It has 2 nitrogens and 6 oxygens. They're just in a different form. Okay, starts with nitrite, ends with nitrate. Okay, that in itself is how the nitrogen cycle that we discussed for our tank relates to the law of conservation of mass. The bacteria that we add is in these 2 bottles. So when we do some testing over there, when we find out we have too much ammonia and too much nitrite, we start adding these bacterias. Okay, and these 2 bacteria in the stability and this night out are the Nitrosomonas and the Nitrobacter. Now, this tank can still be toxic, so we use Prime. Prime can actually take the ammonia and make it unable to be toxic to it. Just binds it, and it makes it unable to be toxic to the fish and harm them. It's still there, but it just binds them for a while. It doesn't last forever. It's a temporary effect. It only lasts about 48 hours. So that's why we've got to put Prime in. We have to put the Prime in every single day. So we do not have these 2 things hurting our fish. The bacteria can still eat those in that form while it's bound, but it's not harming the fish while that's happening. Then eventually, when you have enough stability and enough night out, which he has these 2 bacteria in there, if we have enough of those and it can do their job, it eliminates it and all turns to this really quick and we don't need to add Prime anymore. And then at that point we say our tank is cycled and we no longer have to add this, and it's just a naturally occurring cycle. Now I'm going to walk over here quick And I'm just going to show up here on our Chart in the Classroom board. We are testing for ammonia, nitrite, and nitrate, just like up there. We do test for pH because if the pH changes, these things can become worse. But that is not part of the nitrogen cycle. These three are, and we have those three tests right here. We have our ammonia, we have our nitrite, and we have our nitrate. And we test them every single day. I hope you understand a little bit now how the nitrogen cycle is related to the law of conservation of mass. And these little beauties are happy.